Hello, in this video we're going to explore the composition of functions. Please use your guided notes to follow along. Let's start with the definition. If we're given two functions, f and g, let's call them, they could be any functions, k, p of x, but we're going to use f and g for our definition. The composite function, which is denoted f of g right there, it looks like fog with that little zero in the middle. It's read f composed with g. It's defined by taking f of g of x. So instead of putting just a number or a value into your function f, what we're going to take is the output from g of x. So we're sticking another function into a function. So when we have f of g or f composed with g, that doesn't mean f multiplied by g of x. See here, f of g of x is not the same as f of x times g of x. Please don't multiply the functions. Composing them is actually a lot easier than multiplying them. It means the input of the function g into the function f. So we're going to put the whole function g into the function f. We'll do lots of examples, no worries. The domain of f composed with g is the set of all numbers x in the domain of g such that g of x is in the domain of f. In other words, f of g is defined whenever both g of x and f of g of x are defined. So let's look at this diagram. So we have, in order to find f of g of x, we kind of work from the inside out. You're going to take your value x right here, and you're first going to put it into your function g. So it's going to go through your function g, think of it as a machine, and it's going to come out. That output, g of x, think of it like your y value that you get out of a function. That g of x value then goes into your function f. And that's where you get your final output, what we're looking for, f of g of x. So we put our x value into the function g, or the inside function first. And then whatever we get, we're going to then put that into the outside function. Please note that you can compose more than one function. Here I have f of g of k of x. In this case, we would find out the value of k of x first, and we'd put it into the function g. We'd find out the value of g of k of x, and then we'd put that into the function f. So we're not limited to simply just f of g of x or g of f of x. You can use multiple functions. In your notes, you'll see that we have steps for the composition of functions. We're going to follow those steps to do the examples that you see here. We'll do some examples together and some on our own. So we're going to follow example A as we go through our steps. When we are composing f of g of x, the composition of f and g, we're going to rewrite our function as f of g of x in the nested form, f with g of x on the inside there. That's saying put the g of x function into f of x. We are going to replace g of x with the function it represents. Now, in this example, f of x represents 5x minus 1. G of x is 3x squared. So what I'm going to do is I'm going to rewrite this as f of 3x squared. Now I have my function f of x equals 5x minus 1. So if I'm finding f of 3x squared, that's 5 times 3x squared minus 1, or 15x squared minus 1. That's what our f of g of x is equal to. So we have just found f of g of x, but the problem asks us to find f of g of 1. So we are going to say f of g of 1, we can just put 1 into this composed function. If a given numerical value of x, evaluate the new function f of g of x with this given value replacing. So we can say 15 times 1 squared minus 1, which is just 14. So f of g of 1 is equal to 14. We just found our answer by first composing our function, finding f of g of x, and then evaluating it at the number 1. Now, if we did not know how to compose functions already, to find f of g of 1, what we would have done is follow that model in our notes at the top, where we put the number into g first and then put our result into f of x. So I just want to show you how to do that. In this version, I'd say g of 1 is equal to 3 times 1 squared, or just 3. And then I would find f of 3. F of 3 would be 5 times 3 minus 1, giving me the number 14 as a result. So we're getting the same result either way here. Finding the composed function like we did on the left here is going to allow us to find the composition, or f of g of x, for many different values without taking these multiple steps that we did on the right. For part B, we're asked to find g of f of 1. So we can do that by first, if we want to, take our function and find g. For part B, we're asked to find g of f of 1, as I have written right here. So what we could do first, we can use either method from before. We can find f of 1. So we can plug into our f function, the number 1, 5 times 1 minus 1, or 4. And then we can find g of 4. So that would give us 3 times 4 to the third. And we'll get 192. You could find g of f of x first, which is 3 times the square of 5x minus 1. And if you plug 1 into that function, you'll get the same result as 192. As you can see, when we're composing two functions, f of x and g of x, it doesn't have to be f of g of x. You could do f of g of x, you could do g of f of x, f of x, or g of x. We can compose our functions in multiple different ways, and you can compose them for specific values. I'm going to go ahead and do g of negative 1. First, I'm going to find g of x. So that means I'm going to take my g of x function, and where I see x to the third, I'm going to plug my g of x function in. So what does that look like? It's going to look like 4, and then I will replace this with 4x to the third plus 1, all raised to the third, and then plus 1. Now that I have that, I can plug in my number, negative 1. So g of negative 1 is 4 times 4 to the negative 1 to the third plus 1, raised to the third plus 1. And we can simplify that. You can see here that that simplifies what's in the parentheses equals negative 3. I cube that and get negative 27, and my final result is negative 107. Alternately, we could have found this answer by finding g of negative 1, which is 4 times negative 1 cubed plus 1, and that would be negative 3. And then when I find g of negative 3, I get 4 to the negative times negative 3 to the third plus 1, and that gives me my negative 107. Right now, I'd like you to pause the video, and you are going to try A, B, and C, and then check your answers. What are you waiting for? Pause. All right, check your answers if you're ready. Okay, let's move on. Rather than looking at our traditional equations, you can also compose functions if you have tables of values. So we're going to do that for these examples here. We have on the left, we have x and g of x, and then we also have a table for f of x for given x values. We're going to use that to fill out our table on the right, f of g of x. So f of g of x. So this first one we're finding is f of g of negative 2. So what we're going to do is we're going to find the value of g of -2. That's what's on the inside here, right? So g of -2 equals 4. So we'll go ahead and we'll plug in to our f of x function 4 for x. So f of 4 is 7. So that's our answer there. Again, we just took f of g of -2. We found that g of -2 was 4. So we replaced that in our function and found f of 4. We looked in our middle table here and found f of 4, so 4 for x, was equal to 7. So that's how we got our answer for the first column. Now let's go ahead and find f of g of -1. We'll go ahead in our g column and we'll find out what is g of -1. G of -1 equals 1. So now we'll find f of 1. F of 1 is 4. So f of g of -1 equals 4. Follow the pattern and see if you can find the last three answers. We're looking for f of g of 0, f of g of 1, and f of g of 3. Pause the video, get those answers, and then check. Hopefully you've tried all three at this point and you can check your answers. You can see in orange here the work for f of g of 0. We found that g of 0 was 0. So then we went into our table for f of x and g of x and we found f of g of 0 is the same as f of 0 and we got 3. For in blue, we have here f of g of 1. So we looked for what is g of 1, and it happened to be 1. So then we found f of g of 1 is the same as f of 1, and we got 4. But then when I was looking for f of g of 3, I looked at my g of x table, and there's no 3 over here. There's no 3. 3 is not in the domain of g of x, so we can't put something into the composite function that is not in the domain of g of x. So this one happens to be not possible. We can't get an answer there because we can't put the number into our function. For this video, we can also compose functions using graphs, and you'll see questions like this in your homework. We're going to find g of f of 3 first. G of f of 3. And you can see we have our functions g of x and f of x. G of x I'll highlight there. And f of x is on the bottom. So what we're going to do is we're going to find f of 3. So I'm going to look for my x value is 3 and see what my y value is. My y value there is -1. So this will be the same as g of -1. So now I will look at my g function, which I have highlighted in blue, g of -1, and I get out 5. So f of g of 3 ends up equaling 5. Let's try another one. Here we have g of f of 0. So the first thing I'm going to do is I'm going to find f of 0. So I'm going to look at my f function where 0, and the output happens to be 0. So now I get to find g of 0, and that's on my blue function. G of 0 is 7. So f of g of 0 equals 7. Now let's go ahead and try to find f of g of 3. First, I'm going to look at g of 3 and look at my highlighted g function, 1, 2, 3 for x. My y value is also 3. So now I'll find f of 3. 1, 2, 3, and I get -1. And lastly, we have f of g of 4. And we'll be working from the inside out. So we're going to find g of 4 first and then plug it into our f function. So I'm looking at the highlighted function for g of 4. We'll go 1, 2, 3, 4 for our x's. And our output is also 4. So that's going to be the same as finding f of 4. and f of 4 equals 0. Hopefully you found this helpful. Please move on to the next section to find out about domain of compositions.